Hello, everyone. Good morning from Arizona. Good evening from France. Uh, I'm Nemo. For those who haven't met me, been community member and designer at Local Motors for quite a while. So if we haven't met, hello, and if we have met, good to see you again. We also have Sam, aka Now Break It, joining us. And we're going to talk about the Air Cargo Transporter Challenge based off the Ali platform. There's a lot of questions kind of bouncing around in discussion. Thought we'd like to tackle this in a more live forum, live discussion type of format. First off, we'd like to start with Sam giving a little bit more context in a short, somewhat brief presentation, but with chock full of information. So Sam, feel free to take over. A lot of questions kind of bouncing around the discussion. Thought we'd like to tackle this in a more live forum, live discussion type of format. First off, we'd like to begin giving a little bit more context in a short, somewhat brief presentation or chock full of information. So Sam, feel free to take over.
Okay, thank you. But I think we may have to wait a little bit because some people at least don't seem to have audio.
Huh.
Can you perhaps let us know in the chat if that's a problem? Audio okay?
Fine.
Okay, thank you. Okay, sounds good. Okay, then I'll happily start rolling, and let me share my screen with you. There you go. Should have the screen.
Yep.
All right. Okay, so I'll try to gallop through this presentation a little bit. Do shout out questions in the chat straight away, and we'll get back to them. But we don't want to make this take much longer than it has to and sort of get into the conversation with you all together. So right now, we're talking about the Air Force Cargo Transporter Challenge, and initially I'll perhaps go into the motivation for it, because that is not necessarily super straightforward. If you are not into maintenance, repair, and overhaul operations, they are actually like a huge cost driver around the whole aerospace domain. So we'll get to that numbers a little later. They drive also availability and reliability of aircraft, which is sort of a little different from the civil side, where reliability is the main focus, and in the military aerospace domain, availability is also quite critical. And the whole field is in a dire need of innovation. We'll go into why that is. But on the one hand, we have lots and lots of new technologies coming down the pipeline. And we have sort of a legacy system for MRO. And something sort of has to happen on that front. At first, you may wonder, is it really a good idea to start going on and experimenting in the field of aircraft maintenance? Because one of the issues here is that on the whole, we have this very forward-leaning approach to things, where we take into account that a lot of things will fail on the first try. And this doesn't mix very well with reliability and aircraft maintenance, where things are not supposed to fail sort of ever if we can somehow make that work. And I want to make sure that people are aware that this is like a staged, iterative approach, and that, of course, you will have to start somewhere. And we're not saying any of this will sort of roll out in the next couple of months or a year, perhaps, onto an actual flight line where there's moving aircraft and so on, and perform vital work. But this is to to basically work towards that. And especially this challenge, this first challenge in this direction, is mostly about demonstrating potential. And so we're not asking for anything that is like a super solid solution that you can sort of push into service in the next iteration. But taking a little bit of a step back, we look at official documents, and the Air Force sort of asking for innovation in this domain. Even the Navy is asking for innovation because they see what I mentioned before, lots of technologies coming online, becoming more and more mature, and the necessity of putting them to work in their environment. Now, in this context of the challenge, who's really involved here? Why are we talking about OLLI? So the partner in this context is robotics research, and they are basically working like in depth on everything that makes OLLI drive, on things like the autonomous side, on obstacle avoidance, and so on. There's a video from which I took this frame where you can see sort of the progress that they have made at this point. And we have several OLLIs really in production, but here's the component OLLI, which we'll look at later again, which has been selected to be used in this context. And now if you look at the lower part of the slide, you see like a military budget, and you see that operations and maintenance actually dwarfs everything else. And that's sort of how you can think of that. And especially if you are aware of this F-35 fighter program that the Air Force is rolling out, the procurement cost is something that everyone is very excited about. But you see that the procurement actually is relatively small. It's about 1/3 compared to the MRO part. And so that illustrates really why the MRO is such a super important factor, and why this need for adoption of cost-saving technologies is so pressing. So here's again, this in a slightly higher level of detail. So first you research the F-35, let's take as an example, then you have to produce them all. And then as they are produced and the first one's introduced, you basically have to keep them running. And as they age, they become more and more expensive. And when we're talking about expensive, how expensive is that? This is sort of an illustration on the right side where you can see the cost of the total cost for a flight hour broken down by specific aircraft types. And the F-35, we have like 67 or a little more US dollars per hour. And also, if you look at like a time perspective, 1 hour of flight usually means about 20 hours of maintenance for very rough rules of thumb here. And another rule of thumb that people have looked at is that these maintenance costs tend to increase as the aircraft get older. It's no big surprise. I mean, any car owner will know that. And the effect is, or the dynamic is very similar really to cars, but in many fields aggravated by limited supply of spare parts and issues like increasing complexity of aircraft. I mean, cars are increasing in complexity, and that is reflected in the maintenance costs. But for aircraft, you can imagine this is just so much more drastic of an effect. And then let's look at, again, the part about what kind of maintenance exists in there, what's important to sort of have on the radar there, and also go back to this concern with what's the bit about introducing like immature or emerging technologies into a field that usually, because of its technical complexity, does not react terribly well to anything that isn't very reliable. So here, I just want to show you sort of the situation as is. And you'll have like the different types of maintenance, but also on the right side, you see like what causes accidents. And then the majority is caused by pilots. And then 25% roughly is caused by machine or design issues. And the design-induced ones, those are things that can get fixed on iterations, but in the aircraft industry, that's actually not so easy to do because everything needs to get certified and so on. Whereas if we iterate, we try to move a lot faster, and that will be something that can reduce very easily in our designs. But then the part that is also quite interesting for us is really maintenance. And that's something very few people have on their radar, is that actually when you do maintenance, there's a high risk that you break something like that, you make something worse. And that is about half of those machine cost incidences that arise due to that. And that's actually quite a huge number. And broken down a little further still, those different issues can be because parts wear out, because you have fatigue, like certain metal only lasts for a certain time of strains and stresses, and then they'll sort of age. And then you have break-in periods, you have just random things that you don't really know about so much. But you also have what's so-called infant mortality. And infant mortality is like an issue that if you start, let's say, the engine after a maintenance or teardown, it runs, let's say, for 5 minutes or 10 minutes, and then it sort of stops because someone forgot to put in a certain part when they build it back together again. And this infant mortality is quite high and is quite relevant in our context. So it's strongly connected to mistakes that technicians do while they do the maintenance. And this is relevant for us because what we can do with new technologies, with, like, for example, wearable displays or more interactive maintenance documentation, we can reduce these instances of infant mortality and therefore have like a strong impact on safety in the end. Looking at just general innovation potential, you might actually want to screenshot this one. Although the parts that you need to look at are relatively simple. Now this one chart there is out of a survey of the industry and what sort of emerging technologies they find important here. New repair technology, that's quite simple, as it's different materials come with different repair technologies like composites, and non-destructive testing or non-destructive inspection technology is quite related to that. Composite repair technologies. There's in the helpful links quite a number of things that will give you better illustration of what we're talking about here. But those don't really have to be understood in absolute level of detail. We just need to be able to sort of make a module or plug them and make them work on or with the OLLI platform. And then we have predictive maintenance. We have aircraft health monitoring system. And those really are adjacent technologies where they generate loads and loads of data. For example, like a flight from, Europe to the US generally will create terabytes of data, like hundreds of terabytes. So there's lots and lots of data there to work with. But the legacy maintenance routines do not really make use of that. They do to a degree with when you're looking at engine maintenance, because that is really a field that is sort of developing independent of the rest of the aerospace industry in a way. But the major part of the aerospace industry has not sort of caught up to the potentials there. And then there's additive manufacturing, which is quite obvious that when you're talking about rare spare parts, that's going to be a huge boon. You have drones, you have artificial intelligence, although many people do not think that actually impacts a whole lot, which I think is interesting because I can see a lot of ways how that can help. And then sort of similar, you'll have on the right side a brief rundown of the development of thinking around maintenance and MRO in general. And really, fourth generation, I would say this is a bit optimistic because the fourth generation, we are past the year 2000 now, has still not been applied or taken on to a significant degree. Now, that wraps up in a very small nutshell sort of the field of maintenance. And now I'll transition over to the component ollie. Just again, as a reminder, this is sort of a technology mule or technology carrier, technology platform that can be used to push all kinds of emerging technologies into application. In particular, also because it's autonomous, you can do quite a number of tests, not necessarily around real aircraft, but in field relevant situations that don't cost a whole lot, and you can sort of rip out and put back in systems. And if you make it modular enough, the whole thing can be quite cheap and effectively demonstrate the potential of savings if you did this in like a real environment. And then let's just look at real quick a couple of examples of how things are done currently. Like this is also a relatively advanced version, because oftentimes people run around with handheld screwdrivers. That also they have good reasons for doing that often, but you see how you could work much better with exoskeletons overhead. And the skeleton would basically be like a support that you can put your arm on, so you don't have that much movement, you have a higher dexterity, and it's maybe also recording a lot of the data and feeding that back in, so you have the maintenance operation much more traceable. So loads and loads of potential there. And then here you have a very broad overview of sort of the form factor that a lot of these technologies have. So this is, I think, by HI International, and they are sort of the leaders in military MRO, and you can see roughly that a lot of these devices can easily be combined with ollie or merged with ollie, and therefore can be delivered in an autonomous way. Then you have obviously things like drones that can scan an aircraft from the outside. You have like laser guided profilometry that you can marry with that. And that brings us sort of to like a roundup of lots of different opportunities for emerging technologies. I mean, I only scratched on the surface here, but I want to just open this for discussion at this point, perhaps, and be happy to address the different the issues that you see, and perhaps also concerns that you have with regard to how we run this challenge, or what would be sort of things to focus on a little more than I just mentioned. All right, with that, I'd love to turn back over to Nemo, and we'll dig into the questions then.
All right, sure. Let's. We got some questions coming in. Of course, we had the very first one. Do I need to be an engineer and have a technical background to submit my concept to this challenge? Of course not. Having some context is the goal of your presentation, to inform the design brief in a little bit more depth. That doesn't necessarily mean that they need to go into deep technical depth with their concept. They can just be able to put together conceptually how they see the vehicle interacting within the flight line environment, the tool manager and the hangar environment, the tool shed environment, as well as all the other technologies that you mentioned as well. Even if they don't have an engineering background, just as long as they describe their concept really well. So you do not have to be an engineer. Of course, if you're an engineer, you might have a little bit more uh, knowledge in the field, but that was the purpose of Sam's presentation to help give you some of that knowledge, uh, even if you're not in the industry. I would also note that this video will be able to you will be able to come back to it and see Sam's information anytime you need to, because when we're done, it will be on online. We'll be posting links, I believe. Is that correct, Sam? Post links on the discussion pages.
Yeah.
Okay.
So I'd love to talk in any technical detail. If you have any questions, we can dive into any of that in the questions after this call. Right now, I'll jump in. For example, there's a question: fighters versus bombers, for example. And on the whole, I think the relevant distinction is really type specific. So there's a big issue that you are quite familiar with one specific aircraft type, and you can do a whole lot of, let's say, composites work or so on that, or avionics work. So the breakdown isn't necessarily between big planes or small planes that much, although you do have different types of stresses and typical damages a little bit, or accessibility, for example. Like small planes will be a little more difficult to get into some places than for perhaps big planes. But I would say just in general, it's more going to be a breakdown along the lines of, say, avionics versus structural, and we're focusing more on structural in this context, and not so much, well, perhaps also material related, but fighter versus bombers not going to be a big issue.
The other question that we had is been one that we've heard previously, was I don't want to contribute something in my name that perhaps is not reliable enough and leads to an injury. Is that something you're concerned with? Sam, you kind of opened up your presentation touching on that. Do you want to elaborate a little bit more?
Yeah, so I'd love to talk about this because really we have background, we have talked to people that are experts in that field, and we are really cognizant of the issue that reliability numbers need to be like astronomically high when things actually roll out. But that does not keep us from starting to work on something. And once again, here we are working with a partner, and they have facilities and they have like places where they can test all this stuff without endangering anyone. And we are like several iterations away of coming closer to like an aircraft with actual people close to it or in it at some point. So I think we can really do this move fast and break stuff approach and iterate. We just have to be really careful and review things before we ever get close to like things that are in actual use. And on the same note, we will work with partners who know about that, and this is really the first step to demonstrate like a plausible potential for things, right? Also quite relevant to your entries. You do not have to go into like every minor safety feature that you put on there, even though it's always good to demonstrate that you are cognizant of them and sort of you understand, let's say, the culture around this. But you don't have to have that in a level of detail fleshed out in every minor thing. What's good enough is that you demonstrate the plausible potential for innovation, for cost savings, for perhaps also reliability increases. Because, for example, you take cognitive ergonomics or usability into account, and or you have something that allows people when they have to work like in a surge where, let's say, there were a lot of sorties flown and then all the aircraft came back and they all need maintenance, and then you have to work really hard to keep up with all that work.
Yeah.
And you still need to be reliable around that.
Sam,
So
can I jump
those are
in?
things.
Can I jump in real quick? I
Yeah.
want to add on to what you said because, of course, I agree with everything that you're saying. It's perfect. But in addition to that, from a co-creation standpoint, as a community member for many years before I joined the company, I relied on the community to call me out, as it were. So if I was designing something that was maybe out of scope, maybe I was not taking all the parameters, and in this case, safety, into account, we as a team, as a community team, can say, hey, uh, generally your concept is good. Think about this factor. Think about this factor. That's where I feel co-creation can help tie up some of these loose ends, in that we can politely, hopefully, not too condescending, even though we don't mean to. Sometimes we sound that way, but politely let the community know your concept. I like some of your thoughts and innovations, but be aware of this thing. We already had a community member. I don't know if he's joined us today, Texas Mike, who's gave us so much great information. And this is exactly the type of thing that I'm saying is, as community members, if you have a piece of knowledge that you're willing to share, share it. It's only going to make the overall effort that much better. Um, I'd also like to take this opportunity to segue into the concept that I came up with, which, granted, I didn't spend a whole lot of time with it. I just wanted to get something up there to visually demonstrate some of the concepts that we've discussed. Um, so,
Yeah, I can also jump in on that part if you
sure.
don't mind. Like the example entry is still in evolution, and an important
Yes.
part here is also what kind of questions you come back to with us, like what directions you'd like us to explore in that example entry. So we can sort of use that example entry also as an extension for this call, and go into some more detail on those parts.
Yes.
And if you don't mind, I'll just jump on one of the questions that a Griffey came up with, like,
Okay.
do we have to carry and store replacement parts? So here's
Well,
important to...
I was going to touch on that on
Yeah.
the sample entry. Do you want me to touch on that, and then I'll have you elaborate? Because obviously you're going to bring in all that technical expertise, and I'm just going to bring the conceptual stuff. So I figure we can kind of pyramid off of that. So in this example entry, the way I had envisioned it after reading the brief was very similar to those modules and vehicles that you had shown in your presentation. I saw those as well in my research. That's somewhat where the form factor came into play. And then I thought of it as this module holds a removable storage container that not only contains the tools necessary for the job, which then would be dedicated, or excuse me, deployed by the tool manager based on the nature of the job, whether it be a maintenance, a repair, what have you. They have a database that understands what you need, whether it comes to specialized tools, regular tool set, and parts. The rear part of this Ali derivative would be modular, be able to be removed and put back in with the necessary tools and parts. When the maintenance officer on the flight line needs it, he can go scan his badge in this little area here and be able to get his parts. If there are larger parts, you would get those from the front and it would open like a trunk. Obviously, I didn't do a lot of descriptive slides yet. That's something you and I have already talked about, Sam, but I just wanted to get the general form factor and concept visually kind of described here, with the Ali, of course, as that base platform. So again, feel free to add much more context because, like I said, you're the guy that's going to build the top of the pyramid on that.
Yeah, and perhaps on that note, this is a good point to point out that the combination of design and especially like ergonomic design usability with technical requirements is something that I think will help very many people. Like there is a quite wide spectrum of things that you may want to know about, but many of them are not quite as critical as to be able to combine a certain function with a proper design that has the usability. And that's one of the reasons why, also actually why, if you look at the timeline of the challenge, I think it makes a lot of sense to look at teaming up and having people perhaps even helping various teams with technical aspects, and then having other people work on the functional aspects to nail down, okay, what do the features absolutely have to be able to do, what kind of technologies are included, and what potentials do they bring there. So I think there's a big case to be made for teaming up in this challenge, also to cut down the individual development time you basically have to put in there.
And again, from a co-creation standpoint, just to speak on that, for those who haven't tried the teaming function, it's great. You can do a lot of work on the back end of the platform of the entry with your teammates, and then once you get to your next level of iteration, you can roll that out fairly nicely. I've done the teaming function in different ways in the past. This is way better. And plus doing the teaming function with Sam for this example entry, hoping to have more very, very soon once me and Sam digest a lot more information, since he's just a wealth of knowledge. So, keep an eye out for example entry, and we'll keep an eye out for all of your entries and give the feedback as quickly as we can.
Yeah, very good point. Actually, really, if I see entries that have a team of 2, 3, or more people, there's a high chance that I'll just drop by and I can peek into your team section, and I can try helping out if I see like a discussion happening there. So you can discuss without disclosing all of your ideas to the competition, but I can totally, I'm totally open to helping out every team that puts something on there. So really do make use of that feature.
And do we have any other questions?
There was one about transporting like replacement parts and spares, and I can quite easily tackle that. I think that the most important part is to remember there's a distinction between flight line, hangar, and depot work. So flight line is the things that do happen relatively frequently, and they happen sort of on the airfield. You have to be very careful and safety cognizant there. And that's really also where we see the strength of Ollie, because Ollie is mobile enough. It can roll out, and without much chance of human error in the navigation or in the pathfinding. But you can have a person on Ollie as well. And then the opposite end is sort of the depot end, where like the heavy maintenance stuff is done. And if we're talking about engines, it is relatively rare that you will see an engine being carted out to the flight line. What usually happens is that the aircraft goes into hangar or generally into depot work, and then maybe stays there for months to be overhauled and have engine work performed. And such work also happens generally in a very specialized environment for it. And Ollie is more there to maybe work on the flight line where it's perhaps very loud, where communication is difficult, where you don't want to go and do like documentation because it interrupts your actual workflow and so on. So Ollie can support much better on the flight line. And there's, of course, a number of consumables that go to the flight line. For example, these little screws that people undo and screw back in all the time. Those are things there's loads of them on the aircraft, and there's always going to be a couple that are loose or damaged or something, and so they'll have to be replaced relatively often. But the number of things that have to go out to the flight line is relatively limited, and also you want to be very thorough with not losing anything in the process. Like if you go around, if you lose anything on the flight line, that usually ends up in a major disruption of the rest of the process, because then you have to go looking for foreign objects. And you might want to have, for example, the LiDAR scanner in a high resolution mode that it knows if someone dropped a screw or something like that. It can directly give an alarm because something is different than it was when they arrived.
I also want to point out something that was in one of our previous discussions in regards to, you just mentioned like missing hardware and stuff like that. We had talked very briefly, but it's a great thing to bring up for everyone else. The idea that the Ollie and the cargo transporter could help with inventory maintenance of hardware. You have all these consumable hardware pieces, bolts, rivets, nuts, washers, screws, all these types of things that piece by piece, not only for the safety of them falling out onto the ground, but also since they are consumable, one or two doesn't seem like that much, but from a cost perspective, that adds up really quick. So from a inventory maintenance, that's where you had mentioned previous, and I think it was like a week ago, one of our early conversations, you brought up the idea that inventory maintenance can help control costs as well. And the fact that it would be mobile as well, rather than you have to go to the depot, and pick it up and then bring it back out, that type of thing. I felt like that was very relevant to mention, seeing as how we deal with that here at Local Motors on our R&D build floor and on the production build floor. These are things that we watch very closely. So if the Ollie can facilitate that and also make it mobile and accessible, that's definitely a win.
All right. So any other questions, or should we wrap it up and give them a last chance perhaps?
All right. It doesn't seem that we have any other questions rising up just yet. We'll give it a second with the slight delay that we have with this streaming. See if anything pops up. Other than that, I feel as though there's great information in your presentation. Like I mentioned to the community, you guys feel free to watch this. I believe it's going to be on our Ustream page as well as YouTube. Links will go up. Watch it again, get more of that information. Sam threw a lot of concepts out there in a very short amount of time, which I definitely appreciate you putting that together for us. So yeah, you have all that information available to you at all times. Do we want to make a download link for like maybe a PDF of the slides? Would that be fine?
Yeah, absolutely. We can post that. And also, like I said before, view the whole thing here as sort of an invitation for an ongoing discussion where we go into any number of details that you might be interested in.
And we will be watching those discussion areas like a hawk, knowing that there will be potential discussion rising in the next few days after other people who maybe couldn't have joined us today watch this on their convenience. I'm sure there will be a few questions, maybe in the context of things we've said, or in the context of that maybe they had questions that they didn't get to bring to the discussion today. So we will keep an eye out for those, as well as, like I said, let's see some of those entries pop up, and we'll do our best to stay on top of that and provide useful feedback.
There was a last question on like facilitating teaming up, and we already touched on that, but perhaps we can add to that. Like if you put up a placeholder entry, then you can say, I need, or I feel like I need some help on this or that issue, but I feel like I can contribute the skills on this and that. And that way you can sort of give people a little more information and background on what they're going to get when they team up with you. And I think that's going to be a very helpful thing to do. So don't hesitate to put up at least a placeholder or something like that, so you have like an anchor to discuss anything moving forward. And we're also very happy to support the development of any of those entries. So don't feel like you have to already know the whole way to the finished product, but you can set it up with an idea of what sort of direction it's supposed to go.
Agreed. If there is nothing else, I think that does it. Thanks, Sam, again. Tons of great information, way more than I ever would have thought of. But of course, I'm the designer, technical guy, and that tends to be the roles we play. But yeah, if that's it, appreciate everyone who was able to join us. And like I said, looking forward to seeing what you guys bring to us.
All right, rocket guys.
On that note, we are going to go ahead and sign off. And yeah.